Good afternoon, class. We are looking at practice test number 4, module 4, covering chapters 8 and 9, also section 5.4. Chapter 8, application of trigonometry, polar coordinates and vectors. Chapter 9, system of linear and nonlinear equations. And here's the pledge. Again, just reminding you, when you take the exam on your own. All right, so we're going to cover in this part, section 5.4, right triangle trigonometry, chapter 8, part 1, application of trigonometry. So 8.1, the law of sine, 8.2, the law of cosines. All right, so we want to find CD in this diagram. This is 18 degrees, this is 200, this is 36 degrees, this is 90 degrees. There are various ways of approaching it. For example, this is 180 degrees. So if you subtract 36 from it, you get 144 degrees. So how do we get that? 180 minus 36. If this is 144 degrees, this becomes 18 degrees, angle BDA. Why is that? Well, add all three must be 180. In other words, add these two and subtract it from 180. Okay, so 180 minus the sum of 144 and 18, it's 18 degrees. Now, if you look at this triangle, because these two angles are the same, then these two sides must be the same. If this is 200, so is this one. So AB equals 200, BD must also be 200, because we are dealing with isosceles triangle properties. And so if we look at this triangle, sine of 36 degrees is the opposite CD over the hypotenuse, 200. And so CD is missing, BD is 200, and the product of these two will give us CD. CD is 200 sine of 36 degrees. Putting it into a calculator, roughly 117.557 feet. Now, how many decimals? It depends on how many they ask you. We want to solve the right triangle, which means all angles add up to 180, two angles add up to 90, and the following. So what do we know? A squared plus B squared equals C squared, Pythagorean theorem. Sine of one side is the opposite over the hypotenuse. Cosine is the adjacent over that, and tan is the opposite over the adjacent. Let's throw in the numbers that we have. It has A, B, C. So we have B equals 2, A equals 8. This is capital A, capital B, capital C. Those are the vertices. And so obviously we have two sides. We can find the third side, A squared plus B squared equals C squared. So C squared is 8 squared plus 2 squared, 64. Plus 4 is 68. So C is square root of 68. Square root of 68 is 4 times 17. 4 comes out as 2. That's the precise answer, and roughly 8.24. Now, one of the angles, we can use tangent, and because this side and this side are given, we can say tan of B is 2 over 8. So we want to use the given rather than the one that we have calculated, because maybe we made a mistake. You always use the one that is given. In this case, B becomes tan inverse of 2 over 8, or tan inverse of 1/4. You put it into a calculator, becomes 14.03 degrees, and subtract this from 90, you get the angle A. And we write this summary of all sides and all angles. A girl is standing 20 feet in front of a Disneyland Christmas tree. The star at the top of the tree to the bottom of her shoes makes a 60-degree angle. How tall is the tree? What is the distance between the girl and the star? Draw a diagram. Even if they don't say that, you must draw a diagram and define your variables. So here's the tree, here's the girl, and here's the distance between the two. Standing 20 feet, so this is 20 feet. Here's the height that we are looking for, and here's the distance between the two. So we draw this. This is where the star is. This is 60 degrees. This is 20 feet. The height is x, and the distance between the girl and the star is missing is equal to 20. All right. So clearly, tan of 60 is the opposite x over 20. So x is the product of these two, and tan of 60 is the square root of 3. So 20 square root of 3 precisely, roughly 34.64 feet. A squared plus b squared equals c squared. So 20 squared plus x squared, which is this number squared, or this number squared, is c squared. You put it into a calculator, you get almost 1600. C is the square root of that, which is almost 40 feet. Find AC, distance AC, or lowercase p, where angle A and B are given. Angle A and B are also missing, where angle C is given as 67 degrees. So clearly we are going to deal with side-side angle, and therefore sine law, which says sine A over A, sine B over B, and sine C over C are equal. And of course, the interior angles, they add up to A plus B plus C equals 180 degrees. So what we have is 67 degrees. So sine of 67 degrees, and what we have is 8 over 8 is, what we have is 5, and A is missing, sine of A over 5. Cross product means sine A is 5 sine 67 divided by 8. Now you put that into a calculator, it results in 0.5753. And A must be sine inverse of this number. And the calculator gives us 35.1 degrees. So we have this angle, 67 degrees. We found A to be 35.1 degrees, and B can be easily found because A plus B plus C is 180 degrees. So subtract this from the sum of this and 67 from 180. Okay, the reason is, and it's not possible, by the way. Let me explain the second case first. This is angle A. As you know, sine is positive in the first and second quadrant. So this acts as the reference arc. You can think of it as the reference arc. So this one would be 180 minus 35.1. So there are two possibilities. We could have angle A as 35.1 degrees or 144.9 degrees, but it's impossible. Why is it impossible? The sum of the interior angles must be 180. And as you can see, when you add these two, goes way beyond 180. See, A and B and C must be 180. It's just A and C which is larger than 180. So we don't have a second case because side-side angle is an ambiguous case, can give you any of it. So only 35.1 degrees work. If that is the only one that works, and one of them is 67, the sum of the two subtracted from 180 gives you B. A and C, these two add up to 102.1 degrees, subtract it, and you get 77.9 degrees. So case one works, case two fails. Now we got all the angles, we want to find all the sides, and this side is missing. So again, we're going to use this one, sine of 67 over 8. This is 77.9 degrees. So sine of that over AC. And so again, the cross section, multiply these two, and that means AC is the product of these two divided by sine of 67. And putting it into a calculator results in 8.5, and we can write the missing ones we just found here. AC is 8.5, angle is 35.1 degrees, and angle B is 77.9 degrees. All right. We're going to move on. Reminding you that SSA follows the sine law, and it's an ambiguous case. Sine A is H over B. And in fact, I want to go to the previous page and really explain this in the following manner. When you get to this one, everybody, this will result in the following situation. One angle and it works, maybe two angles, or if this number is larger than one, less than -1, that doesn't give you any solution. So that ultimately you end up with a number here that may be larger than one and it doesn't give you a solution, a number that results in one or a number that results in two cases. That's why it's an ambiguous case. So that's what happens here. H is equal to B sine A. If A is smaller than B sine A, we have no triangle. If it's less than A, and A is less than B, then we have two possibilities. We have this one, and the bigger case, the entire triangle. So that's why we end up with different situations. Let's look at this case and let's assume this may not be to scale. So let's assume this is angle A is 50 degrees, this side is 2, this side is 3, and now we want to figure out the rest of them using the sine law. So obviously, we're going to say sine of 50 over A, which is 3. So we're going to go with that, right? Sine 50 over 3 equals sine B over 2 equals sine C over C, where both of them are missing. These two are missing. So we can use these two and do the cross product. Sine B is the product of these two divided by 3, 2 sine 50 divided by 3. You put that into a calculator and you end up with a number 0.511. So if you take the sine inverse of this number, that gives you the value of B. So B is sine inverse of 0.511, which is 30.7 degrees, almost 31 degrees. So that's one case. And this works as a reference arc. Subtract this from 180, and you get 149.3 degrees. This will create a set we are going to finish. Does this create the second set? Well, add this one to 50, everybody. Because it goes beyond 180, this doesn't produce any triangle. So that's impossible. So we're going to continue with this. We're going to add these two and subtract it from 180. We get the last angle of 99.3 degrees. So we have all sides, all angles, I mean. And now we're going to use this one, sine of 99.3 degrees divided by C. And C is the product of these two divided by sine 50. Put it into a calculator, you get 3.86. And we write the summary of everything that we found. Draw and solve the triangle A, B, C. Three sides are given, and clearly we're going to go with the side for cosine. So the sides are given. So if you solve for cosine A, you get cosine equals B squared plus C squared minus A squared over 2BC. So B squared is 9, C squared is 36, minus A squared is 64. 2 times 3 times 6. 45 minus 64 is negative 19, and this is 36. So cosine is negative 19 over 36, which means A is cosine inverse of this number, and the answer is 121.86 degrees. Because all three angles are missing, the second angle also we use the cosine law. You could use the sine law because you found one of the angles, but we're going to continue with the cosine. So I hope you understand, if cosine A is this, cosine B must be A squared plus C squared minus B squared over 2AC. And so a squared is 64, c squared is 36, minus b squared is 9. The bottom is 2 times 8 times 6. 6 times 8, 48 times 2 is 96. 64 plus 36, 100 minus 9 is 91. So we have 91 up here, 96 down here. And b is cosine inverse of that number. You put it into a calculator, you get 18.57 degrees. So we got two angles. The third one, all we have to do is subtract the sum from 180. So we add these two, we get 140.43 subtracted from 180, and that gives us 39.57 degrees. We got all the sides. Now we have all the angles. Find the area. Area of a triangle from sides. Use Heron's formula. Area is A equals square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2. Remember, A plus B plus C, you add up the sides is the perimeter. This is called S because it's a semi-perimeter. So first add up the side, divide by 2. That's S. That means 8 and 3 and 6. Okay. 11 and 6, 17 divided by 2 is 8.5. Put it into the formula that you have here. So square root of 8.5 times 8.5 minus 8, 8.5 minus 3, 8.5 minus 6. Square root of 58.4375 is about 7.644. So that's how you come up with the answer, everybody. We want to solve this triangle. B is 45 degrees, C is 95 degrees, lowercase c is 5. So let's do a drawing, and this is side angle. Okay, we have two angles. So use the sine law. First of all, let's just throw in what we have. And it doesn't have to be to scale. It should give us an idea. So we have 45 degrees. One of them is 95 degrees. Lowercase c is 5. A and B are missing. Obviously, we have two angles, so add them up, subtract from 180. That would be the third one. So 180 minus the sum of 45 and 95, which is 140. So the result is 40 degrees. And now we use the sine law. So what is given? This one and this one. Sine of 95 over 5, sine of 45 over the missing b. So the product of these two and the product of these two are the same. Therefore, b is the product of these two. Let me just cross product, everybody. So b is 5 sine 45 divided by sine of 95. To put that into a calculator, it gives you the result. B becomes 3.55. So now that we have this side, we are moving towards this one. And again, we're going to use what we have. Sine of 95 over 5 we have. We're going to keep it. Now, sine of A over A. Sine of A, we found A to be 40 degrees. So sine of A, sine of 40 degrees over lowercase a. So to find A, we multiply these two, we divide by sine of 95. And putting it into a calculator results in the value of A being 323. And we can write what we had and what we came up with in one shot. That's the summary of the sides as well as the angles and what they should be. Again, reminding you, uppercase represents an angle, lowercase represents the side, the opposite side. So capital C, lowercase c, okay? Uh, A is 55 degrees, C is 20 degrees, A is 4, and we're going to draw a diagram and solve this. And again, we have side and two angles. Obviously, we first find the third angle and then we use the sine law. Let's look at what we have here. We have 55 and 20 degrees. So this must be 180 minus the sum of those. So 180 minus A plus C. 55 and 20, they add up to 75. Subtracted from 180, and we have all sides, all angles, I mean. So now we use the sine law, sine of 55 over 4. The reason we use these two, because we have both of them. And then doesn't matter. This one, this one, this one, this one. In this case, both of them have to be calculated. In this case, only one. Sine of 105 over B. That means 4 times sine of 105 divided by sine 55 must be B. Putting it into a calculator results in 4.717. Now, again, we use the same thing, but this time sine of 20 over C. So C is 4 sine 20 over sine 55. Putting it into a calculator results in 1.670. We can summarize the information given with what we just got. A is 55, B is 105, C is 20 degrees. Lowercase a is 4, lowercase b is 4.717, and lowercase c is 1.670. As far as the number of decimals class, you really want to pay attention to what they ask you, okay? Use the law of cosine to prove cosine A over A, cosine B over B, cosine C over C, they add up to A squared plus B squared plus C squared over 2ABC. I'm reminding you what is the sine law. what is the cosine law? And from the cosine law, I'm reminding you cosine A is b squared plus c squared minus a squared over 2bc. And accordingly, cosine B is a squared plus c squared minus b squared over 2ac. And cosine C is a squared plus b squared minus c squared over 2ab. When you want to prove an identity, you start from one side, normally the more complicated side. In this case, it appears that the left-hand side is a little bit more complicated. So cosine A over A plus cosine B over B plus cosine C over C, because we want to add them up, and that means we have to come up with the LCD. I hope you see that the LCD is ABC. So the LCD is ABC. What is in the numerator? We are going to figure it out in a moment. So this one gets multiplied by B as well as C. So this one is BC cosine A. This one gets multiplied by A and C. AC cosine B. This one gets multiplied by A and B, therefore AB cosine C. That would be the numerator. Now, as we look at the right side, we notice the denominator has 2, everybody. So we can put a 2 here. If I want to put 2 here, that means I'm going to multiply the denominator by 2. I have to do the same thing. So I'm going to multiply everything by 2, meaning this by 2, this by 2, this by 2, and I'm going to distribute it, and the bottom is 2, because I want it to look identical. Okay? Now, how do I get this? I'll go back here. Cosine A is b squared plus c squared minus a squared over 2bc, and I can multiply this by the denominator, 2bc. So let's multiply this by 2bc. Let's multiply by the denominator in essence. So when I multiply by 2bc, this becomes 2bc cosine A, and this becomes b squared plus c squared minus a squared. I'm going to do the same thing here. Look at this one, everybody. If I multiply by 2ac, I get 2ac cosine B is equal to the numerator. So 2ac cosine B is equal to the numerator, a squared plus c squared minus b squared. And this one, if I multiply by 2ab, 2ab cosine C is equal to the numerator. I get 2ab cosine C equal to the numerator, a squared plus b squared minus c squared. Now, I'm ready to replace each one. So take a look. This one, I can replace it with this one. 2ac cosine B, I can replace it with this one. 2ab cosine C, I can replace it with this one. And I do that. I cancel those two. I cancel those two. I cancel those two. So I'm left with b squared, c squared, and a squared. I put the a squared first. The final answer is a squared plus b squared plus c squared over 2ab, and that's exactly what we have. In other words, we just proved through the law of cosine that cosine A over A plus cosine B over B plus cosine C over C equals a squared plus b squared plus c squared over 2abc.